How are you guys doing today? Hi, Nitya. I am actually not doing well. My throat is burning a lot, and I feel like I'm going to get cough in next few days, within next few days. But I don't know how to stop that. So I'm worried. But thank you so much for your hello and hi. How all of you are doing? Walaikum salam wa rahmatullahi wa barakatuh, Fatima, and everyone else. All Muslim students, Assalamu alaikum. And to everyone else, hello. You also sick, Tahmina? I hope you get well soon, but don't get more sick. Today is Wednesday, yeah. So next week we have class only Monday. How is the semester going so far? So in this semester, I'm teaching 2 classes at Baruch, 1 class at Hunter, and I'm also taking 2 classes at Columbia. So I have a packed schedule, but I'm doing great so far. Alhamdulillah. Thank you, Tahmina. My grading will start next week. I have to give exam to 2 of my classes at Baruch, and then I have to give your exam when you come back from the vacation, our mini vacation to you guys. So I have to do grading. Thank you, Christina. So we are actually done with 5 chapters already. We skipped chapter 5. We're going to do that at the very end of the semester. And today we're going to start chapter 7. Let me remind you of your homework. Whenever we do any section from any chapter, after the lecture, try to do the homework. So your memory still will be fresh when you do them. And it's a better way of practicing what we learn in class. Okay. So even though I don't push you guys to do the homework, but it should be your job to do the homework. And remember, homework is 20% of the grade. So if you don't do that, that means you're losing your 20% from 100%. So you're betting a grade on 80%. So you're definitely not gonna get to B, A, or A minus if you don't do your homework. Hey guys. So do any of you have any question, comment, concern, or complaint at all? Nothing? Okay. So today we are going to learn something kind of fun. The exam has everything. Multiple choice, fill in the blank, true, false, and written question. Mostly written question like math, and probably 30 points, 30 to 40 points on multiple choice and everything. If you're talking about homework, they actually grade your homework based on correction. So whatever you have points for being correct, that I can see on website. So I take the total points they give me. So it's not completion, but actually it's based on correction. How Since we have only 1 hour and 15 minutes for our exam, so probably around 10 math questions, and the rest is just multiple choice, fill in the blank, all those. Yes, I'm going to post the review sheet over the weekend. So since we are almost, I mean, we're starting chapter 7, so most likely we'll be able to finish this before. So next week we don't have any class besides Monday and Tuesday. So we're not gonna have any Wednesday class. And then let me actually pull out our syllabus so you can see everything there. Okay, so today we are going to do lecture 8. Next week we'll meet for lecture 9. Oh, and then next Wednesday we have no class. Then we have 2 classes. Then we are gonna miss 1 class. And your exam will be on 21st. So on 13th lecture. So most likely we'll be able to finish chapter 8 also. So might be maybe our exam will be from chapter 1 to chapter 8. And let's see if we can do chapter 9 also. If not, it will be fine. But I'm gonna make the review sheet up to chapter 9. Chapter 9 is not sure yet. We'll see. When our exam 1 will be, it's Monday, 21st, October 21st. So almost a month, after a month. Wow. So when the exam time comes, I think you're gonna forget most of the materials we learned. So I'm gonna post the review sheet soon, and you should just review the materials. The review sheet will be based on our lecture notes. So I'm not gonna have any solution or answer. It's just based on lecture notes. All the questions we do during classes, I just take questions from there. And so all you have to do is look at your notebook and collect all the solutions into one place. So you can review them every day or at least once a week. Okay. Very similar. But in the review sheet, I'm not going to give any multiple choice thing. The review sheet is based on just math portion. So for the multiple choice, during lecture, every lecture I actually mentioned, this will be a good question for exam. So for multiple choice and those, we just have to see during which part I said this topic is a good topic for exam. Okay, Mia, no problem. But try to message me on the everyone openly, because once I start lecture, I actually can't open my chat box often. Okay, any other question? No. So in chapter 6, we talked about probability, and we learned so many things about probability. Now we are going to do more probability, but this time we are working with probability distribution. And we are going to learn 3 types of probability distribution. One is discrete probability distribution. There we are going to learn how to find mean and standard deviation of a random variable. Then we are going to talk about binomial probability distribution. And they have their own way of finding mean and standard deviation. And then lastly, you're going to talk about normal probability distribution, where we're going to use this D formula to convert any type of distribution into normal probability distribution. So first, we start with some definition. I'm so glad this class is online. So I'm talking very softly, but in class I have to talk louder, and it stains my throat. Anyway, random variable. It's a variable whose value is determined by an outcome of a random experiment. So we do some random experiment, whatever we get based on the outcome, we get random variable. Discrete random variable is a random variable that can only take a finite or countable number of values, or if it's sets of values in a collection of isolated points on the number line. In other words, when you work with discrete random variable, our random variable has only whole numbers. We don't have a fraction, we don't have a decimal. All the variables, all the number we have for the variable is whole number, like 1, 2, 3, 0. Some example is number of items purchased in a store, or number of broken eggs when buy a case of eggs. So those are whole numbers. So discrete random numbers. On the other hand, continuous random variable deals with everything else, decimal points, everything. And we work with an interval where we have infinite number of values. For example, time. Time is represented by an interval, like from this time to that time. So it's an interval, and time could be decimal. Same thing, height, or height could be like 5 foot 7 inches, 4 foot 3 inches. So those are not whole numbers, those are decimal numbers. Same thing, weight. We definitely don't always get whole number weight. We get decimal weight. For example, 51.3 kilogram or pounds, blah, blah, blah. Now, probability distribution of a discrete random variable is a probability, the probability distribution of a discrete random variable x is a list of each possible values of x together with the probability that x takes that value in one trial of the experiment. It means we just put together all the information. When we do one experiment, how many outcomes we get, and for each outcome, what's the probability we have. This is called discrete random variable, the probability distribution for the discrete random variable. And we can usually use table to represent that, or you can use histogram or bar graph or formula. Now, rules for discrete random variable is same as chapter 6. All those probabilities must be between 0 and 1. So you cannot have any probability that is more than 1 or less than 0. Plus, when you add all the probabilities in the table, they must add up to be 1. One example, let's say we are flipping a coin 3 times. Now we can make the probability distribution table for this experiment. So let's do it together. Give me 1 second, let me get my phone. Any questions so far from anyone, guys? Nothing. So we are flipping a coin 3 times. And we want to see number of tails we receive in each trial. Okay, so either we can get no tails at all, or we can get one tail, or we can get two tails, or we can get maximum 3 tails, because we are doing it 3 times. Okay, now we want to figure out what is the probability for each of these outcomes. So that means let's start with our sample space. So one of them is head, 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 and one of them is tail, tail, tail. Now, can you kindly tell me what other choices we're gonna get when we flip a coin 3 times?
Head, tail, tail.
Head, tail, tail. Next. Head, tail, head. What else? Tail, tail, tail. Okay, I already got tail, tail, tail. Tail, tail, head. Anything else? Tail, head, head. Tail, head, head. 1, 2, 3, 4, 5, 6. I need 2 more. Let me make them smaller. I forgot what did I erase.
Tail, head, tail.
Tail, head, tail, tail, head, head. Tail, head, tail, tail, head, tail. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Tail, head, tail. Tail, head, tail. And lastly, tail, tail, tail. 67, this is it. How did I know that we are going to get 8 outcomes? You guys remember how to figure out what would be the sample size? Not sample size, sorry, size of the sample space. How do you figure that out? Did you remember? Nobody remembers? Okay, we learned it at the beginning of chapter 6. Very beginning of the chapter 6. Size of the sample space. Let me change the color. Size of the sample space. Its number of possible outcome to the power number of trials. So when you flip a coin, we have 2 possible outcomes. And you're flipping the coin for 3 times. So we must have 8 outcomes. Yep. We can use a tree diagram, but this is how we find it for any size. So when we have, let's say we are doing the trial for 10 times, then there is no way we can do tree diagram. But still we need to know what is the sample size. Sorry, not sample size, the size of the sample space. So this is the formula. It's number of possible outcome to the power how many times we are doing on our experiment. Okay, anyway. So in all these 8 outcomes, how many times you see zero tail? We are counting all the tails. So how many times you have 0 tail? Do you notice anything in our sample space? How many of these outcomes have no tails at all? Good job. It's 1 out of 8. Only when we have head, that time there is no tail. So it's 1 out of total 8 times. Since we are doing probability, we must have to have a fraction or decimal. Okay, so among all this sample size, how many times we have only 1 tail? 2? Okay, let's see. Here we have 1 tail. Here we have 1 tail. Did I make a mistake? Do I have the same thing 2 times? Head,
Oh, you
tail,
have
tail.
head, tail twice.
Yeah. Which one I have twice?
THT 5 and 7.
5 and 7. Oh yeah, that's why.
You're
So which
missing
one is I
head,
missing?
tail.
Head, tail.
Tail.
Okay. So yeah, my mistake. Sorry. Thank you for catching that. So we have actually 3 of them. 3 out of 8 times we have only 1 tail. Now we need to count how many times we have 2 tails. 1 here, 1 here, and there is 1 more here. So we have 3 times again. Oh, 3 times we have 1 tail, 3 times we have 2 tail. So how many times we have all tail? Only 1 out of 8. This one. Now, if you observe, you see if we add all those probabilities, we get 3 plus 3, 6, 7, 8. We have the sum of all the probabilities is 8 out of 8, which is 1. That means, yep, our probability distribution is correct. If we didn't get sum of 1, that means something is wrong. So this is a probability distribution, discrete probability distribution. Based on our trial, we get the probability and we put all the information together in one table. Any question? Okay. Then let's try this together. We have, this is from homework. We have X be the number of courses for which a randomly selected student at a certain university is registered. So you asked one student how many classes he's taking. And all the students in that school, they have either 1 classes to 7 classes they are taking. So probability that the student you asked is taking 1 class is 0.03. Or the probability that he's taking 2 classes is 0.05. The probability that he's taking 3 classes is this. So 1, 2, 3, 4, 5, those numbers are how many classes students are taking. And P of X means what's the probability that the person we are asking, what's the probability he's taking that many classes. Now, if you observe, we have the maximum number of classes we can take is 7. However, they did not give us the probability for 7. So it's our job to figure out what is the probability that he's taking 7 classes. Any idea how you're going to figure this out? You already done, Shion? How did you figure that out? What did you do? Enlighten us with your wisdom. How did you figure this out? Good job. It's 1 minus sum of all the probabilities. In other words, 1 minus 0.03 plus 0.05 plus 0.17, which is 0.06. Because when you add all of these, the sum must be 1. So if you're missing one of them, that means it's 1 minus the rest. Good job, guys. Now more questions. What's the probability of selecting a student who is taking at least 5 courses? It means you're asking someone randomly, what's the probability that he is taking at least 5 classes? The question is, what does at least 5 courses means? Now tau is done, 0.59. How did you do that, tau? At least 5 courses means what? Either they're taking 5 classes, or they're taking 6 classes, or they're taking 7 classes. So we go to the probability section and see what's the probability from 5 to 7. Oh, cool. Blue and yellow makes green. Wonderful. So we found that this is 0.06. That means we are going to add 0.36, 0.17, and 0.06. Together, 0.59. I'm not doing any math, okay? I'm just trusting your calculation. So all of you should try this. Just because you know this is easy, it doesn't mean you should not do this. Trust me, in the exam, you may get confused what to do. So if you do practice with me, it will really help you. It will help you during an exam. So is he correct, everyone? Did you get to the calculation by yourself?
Yes, correct.
Wonderful. Thank you, Christabella. Now the next one. They look same. The only difference is B says at least, C says at most. So this time what you're going to do? Now Fatima is done, 0.77. So what did you add, Fatima? How did you figure that out? You added everything 1 from 5? 1 to 5? Okay, at most means either 1 class, or 2, or 3, or 4, or 5 plus. That means we're gonna add all the numbers. 0.03, 0.05, until the 5th class, 0.36. And that will give you 0.77. Is the calculation correct, guys? Is her calculation fine? Did any of you did it yourself? Come on, when I ask you any question, it means I hope to get some answer. Thank you, Tao. We have 3 more questions. What is the probability that x is between 4 and 6, greater than or equal 4 and 6? I mean, between 4 and 6, and between 4 and 6 without the equal sign? And what's the difference between the question D and E? So Oh, probably need to see the chart. So write down the question and then I'll show you the chart again. So we are doing all the numbers here and here. Now look at the chart. What would be the answer for D and E and F? Ready? So what you're going to add here? Probability X equals what? Oh, good. It says 4, between 4 and 6, including 4 and 6. So you're going to add probability of 4, probability of 5. I missed my X. X equals 5 and probability X equals 6. So 0.24, 0.36, and 0.17. Whatever that is. 0.77? Okay. Cool. But then what's the difference between D and E? What you're going to do for E? Probability of X equals? Good. This time it says X is strictly between 4 and 6. We cannot take 4, we cannot take 6 because they don't have the equal sign. So there's only one number we are looking for, which is 5. And the answer is 0.36. So how the answers D and E different from one another? What can you say about F? In D, what? We add probability of 4 to probability of 6. But in E, we get only probability of 5. True. In E, we don't. So obviously, D gives us a higher answer than E because they have more probabilities to work with. So, any questions so far about any of the parts we did? Anything at all? No. So this is the answer. And now we are going to find the mean and standard deviation of discrete variable. So when you work with a data set, we said the mean is sum of all the numbers divided by how many numbers we have. But this is not the case for discrete random variable. In discrete random variable, we have the number for variable and we have their probabilities. So the mean is the sum of the product of the variable times their probabilities, the values, and then the product of the values with their corresponding probabilities. We add all of them, whatever we get, that's the mean. And sometimes we use the word mean, or sometimes we use the word expected value. They represent the same thing. Basically, it means find the mean. So we are given a chart with X values and their corresponding probabilities. To find the mean, all you're going to do is multiply each of them column-wise and then add them. So our first X is 0, 0 times 0.5. Next one is 1, and its probability is 0.3. Next is 2, its probability is 0.2. So multiply each value with its probability and add all of them together. So this cancel out. We have 0.3 plus 0.4. That gives us 0.7. Clear? Any question? No? Okay, then you try one. Answer this question. Find the mean. And then one more thing. What's the probability that this X, exceeds the mean? It means how many X values do you have that is bigger than mean? We add the probabilities. So let me know when you're done. All of you should try this. Wow, Shian is already done. So if found the mean is 1.03. Yes, mean is a number. It's not probability. So mean could be anything. Only probabilities cannot be more than 1 or less than 0. So what did you do, Shian? Anton, thank you. You are giving me the details explanation. 0 times 0.54, 1 times 0.14, 2 times 0.07, and 3 times 0.25. They all add up to 1.03. Wonderful. So, what do we have for B? What is the probability that our X exceeds its mean value? Yep. So if you observe, since our mean is 1.03, it's somewhere here. So it says which X values exceeds mean. So these two X values, they exceed the mean. So our mean is 1.03. X values bigger than mean are X equals 2, X equals 3. So they're asking for probabilities. So probability that X exceeds mean, it means what's the probability X is bigger than 1.03. In other words, probability X is 2 plus X is 3. I'm writing all the details so that you can understand them. We don't have to write all the details in the exam. 0.07 for 2 and 0.25 for 3. That gives us 0.22. So basically, they're asking what's the probability that we have something that is more than mean? It's only 32%. Not bad. Who is lost? Anybody? Okay, Yusuf, tell me which part you did not understand, A or B? Which one, A or B? B? Okay, so did you understand the question? I mean the English. Did you understand the English version of the question? What is the probability? It means you're going to find probability that X exceeds its mean. You know what it exceeds, right? It means bigger. X is bigger than mean. So it says, what's the probability that if you pick an X value randomly, it will be bigger than the mean? So we found our mean is 1.03. So the X values we have in our chart that are bigger than mean is X value 2 and X value 3. So what's the probability that you are going to pick X value 2? So we just add the probabilities. No problem. So most of the time, math itself actually is not hard. It's the way they the way they state their question. It's confusing. I hate that. But anyway, thank you for asking, Yusuf. Anyone else who is still confused? This is actually one of my favorite questions because it came to other final. Not last semester, but semester before that. So who knows? Maybe department will put this type of question in your final. So it's a good practice. Now it says find the variance and standard deviation. Well, if you know variance, you're gonna find the standard deviation automatically because standard deviation is square root of the variance. That's why they give us a formula for the variance. They don't give us a formula for standard deviation. Because to find the standard deviation, you must find variance first. And variance and mean, they actually are very similar. To find mean, we multiply x with the probability. But to find variance, we are going to subtract the mean from each x value, square the quantity, and then multiply the probabilities. It's almost same. Mean is sum of x times p of x. And our variance is sum of x minus mu squared times p of x. But there are other ways to find it. The same formula we can write differently. So usually if you go to higher level statistic or higher level probability classes, you're going to see the alternative formula instead of the baby formula. The left page has a baby formula and the right page has more advanced formula, but they're the same thing. So whatever you prefer, you can use that formula. Okay, one example. Suppose that for a given computer salesperson, the probability distribution of X is the number of systems sold in 1 month, and it's given by the chart here. So the probability that the salesperson sold one computer in 1 month is 0.2, I mean 20%. He sold 2 computers, it's 40%. He sold or he's going to sell, whatever that is. Probability of selling 3 is 0.17%. Probability of selling 4 is 0.23%. Now they want us to find the mean, standard deviation, variance, all of them. Okay, so go ahead, try it. The mean is same thing as what you did in last example. Once you find the mean, you can use the baby formula. Let me write down the baby formula here also. Variance is x minus mu square times the corresponding probabilities, and you add all of them. So it means 1 minus whatever you got squared times 0.2 plus 2 minus whatever you have for mean times 0.4. This is what it means. Thank you, Anton. You're already giving me mean. Wonderful. So mean is sum of all the x times the probabilities. 0. Really? Oh, you square for variance, not for the mean. So let me write down the mean. And you keep doing this thingy. Variance. So mean is 1 times 0.2, 2 times 0.4, 3 times 0.17, 4 times 0.23. 2.43. Is he correct, guys? Are you guys doing it yourself? Yes? Thank you, Salma. All of you, I want all of you to try it. Great. Now next, find the variance and standard deviation. So variance is sum of x minus mu squared times each probability. Oh, Shiani is done with the probability. Oh, it's 1.0. 1.1051. Okay. All of you should do it and let me know if he's correct or not. So Shian, what did you do? What did you add? What did you multiply? How did you find it's 1.1051? In the exam, remember guys, you must show the details. Otherwise, I'm not going to give you credit. Even if you use calculator, but still you have to show the details. How did you figure that out? Like the way Anton did. He showed mean, and then he showed the multiplication. It's a bit confusing. No problem. I'm just waiting for anyone to give me the first step. So definitely we're going to do it together. So Christabella, actually you help me. It is x minus mu. And we have 4 of the x's. So what is your first x value on the chart? It's 1, right? It says from the x value, subtract the mean. So we found the mean on the left page, 2.43. So from your x value, you subtract the mean and then you square the quantity. Whatever you got, you multiply that by the probability for x equals 1. So x equals 1 has probability 0.2. So you multiply the difference, the square difference by 0.2. And this symbol is called sum. Sum means you're going to add all of them. So next x value we have in the chart is 2. So this is x equals 1. Now we are going to x value 2. And we're going to do the exact same thing. We're going to subtract the mean 2.43. We squared the quantity so that we get a positive result. And we multiply by the probability for x is 2, which is this time 0.4. Then you go to the next x value. Our next x is 3. So it's 3 minus 2.43 squared. We multiply by the probability for 3, which is 0.17. And finally, we go to the last x value, which is 4. We subtract the same thing. We square and we multiply by the probability for 4, which is 0.23. Is it clear now, Mr. Bella?
Yes.
Okay, great. So is this 1.1051, guys? Yes. Wonderful. That means the last thing we need to do is find the standard deviation. So what you're going to do? Lacy, gracias. Standard deviation is what? Square root of the variance. In other words, it's square root of 1.1051. And that gives us how much? 1.051. 1.051. Wow. They look same. Surprisingly same. Okay. So you may see this in the in-class exam or in the final exam. In one of the places you're gonna see this. Any question? Was any step unclear to anyone? Remember, you have lots of homework on this. Discrete. Go ahead, Yusuf. You can actually
Yeah, I'm sorry. Yeah. So can you go back to the equations for a second for variance? When I plugged into the calculator, like I think like by mistake because I didn't understand the equation, I just put in like 1 squared times like the 0.2. I didn't minus 2.43 from the 1 in each bracket because I was following this red formula, and I still somehow got the same number.
So these two formula are actually same. This formula and this formula, they're same. They look different, but they're same thing.
All right, I was just making sure if it was like all right or not. Okay, thanks.
No problem, Mia. So whatever is easier for you guys, you can use either one of them. But whatever you do, make sure you show work. Otherwise, even though the answer is correct, I'm not going to give you any point. Not even partial credit. Any other question? Oh, it has more parts. Ram is what? Question, or you use the second method and found the same answer? Or you're talking about the Wi-Fi thingy? Wi-Fi? Ah, okay. No problem, I understand. What is this? I don't want to find that one. Okay, what is the probability that the number of systems solved is 2 standard deviation away from its mean value? 2 standard deviation away. What does that mean? And we have the next one. 2 standard deviation within the mean. So 2 standard deviation away from the mean and 2 standard deviation within its mean. What's the difference between them? And how do you find them? Any idea? I actually forgot what to do. What's the probability that number system solved is 2 standard deviation away from its mean? So we have to find how much we have for 2 standard deviation. So let's see. Our 1 standard deviation is 1.051. So 2 standard deviation will be 2 times 1.051. That will give us 2 times 102, right? 2 times 1 is 2, 2 times 5 is 10, 2 times 1 is 2. 2 standard deviation away from mean. Away means exactly. So area means if our mean is here and we are finding something that is away from mean, it means we want to find anything that is below or that is above. So this is away, not near, away. On the other hand, within the mean, if this is our mean, mu, within the 2 standard deviation, it means close to the mean, next to the mean in 2 standard deviation, both directions. Does it make sense? Area means you're far from it, but within means you're close to it. So the answer to the left one will be, this portion is mu minus 2 standard deviation, and this portion here is mu plus 2 standard deviation. Sigma is the standard deviation, I forgot. So mu minus 2 standard deviation, mu plus 2 standard deviation. So we have to see what is mu minus 2 standard deviation. Our mu is 2.43. We're subtracting 2.102. Whatever that is. I'm gonna write this above. Mu minus 2 standard deviation. 0.3, 0.328. And mu plus 2 standard deviation is 2.43 plus 2.102, 4.532. So anything that is smaller than, so this thing here is 0.328. We are looking for anything smaller than 0.3 or anything bigger than 4.532. So let's see in the chart, anything smaller than 0, nothing exists. Anything bigger than 4.5, doesn't exist. So answer here is 0%. Because there is no probability there. We don't have any x value that is smaller than 0 or bigger than 4. So we have nothing that is 2 standard deviation away from the mean. So let's see, what do we have 2 standard deviation within the mean? So this here is 0.328. This here is 4.532. So anything between x is 0.32 to x is 0.45. True. The chart we have, it's everything is between 0 and 4. That means to find the probability, we just have to add all these things. And you already know when you add everything, that must be added to 1. So here the answer is 100%. Who is lost? This is like a mental game. Not mental game, like kind of logic math. Okay, so which part you did not understand? Like the word area within those or the math itself?
Yeah, can you go over like the area part again? I just like missed visualizing it.
Okay, so in our chart, let me draw the chart here. Let me change the color to red. In our chart, we have the x value 1, x value 2, x value 3, and x value 4. So our chart is lying within these 4 numbers. Now on the left page, it says, what is the probability that he sold something that is 2 standard deviation away from the mean? So we found that when we calculate 2 standard deviation, we have our smallest number is x equals 0.3 and the largest number is x equals 4.3. So somewhere this is 2 standard deviation, 0.3, and here we have 2 standard deviation, 4.5. Okay. Now it says, what is the probability that he is away, 2 standard deviation away from the mean? Away from the mean means something that is less than 2 standard deviation or something bigger than 2 standard deviation. So remember when you say go away, it means go far from us. So away means
Okay.
far.
So using the mean, you have to go 2 away and in both directions, and since it's not within that range, that's why it's 0%.
True, because our mean is
Got it.
somewhere
Okay.
here. This is our mean, 2.43. So 2 standard deviation far from the mean is anything smaller than 0.3 or bigger than 4.5. But look at our chart. It's only from 1 to 4. We have nothing there that is away from the mean, 2 standard deviation away. The next question is asking, what's the probability that you are within 2 standard deviation mean? So within means next to or close to. Like when you say, well, we have this store within somewhere this area, within 50 meters of our 50 miles, sorry, 1 mile from our house. Within 1 mile from our house, we have this store. What does that mean? That we have that thingy is close to our home, within 1 mile of our home. The same thing here, 2 standard deviation within the mean. It means next to the mean, 2 standard deviation. This area. What is the probability that you are within this area? 2 standard deviation A from the mean. Sorry, 2 standard deviation within the mean. So look our chart. The whole chart is within 2 standard deviation because our chart is lying from 1 to 4 only. But we are even smaller than 1 and bigger than 4. So definitely everything in the chart is lying within 2 standard deviation. So 100% of the information we have is within 2 standard deviation of the mean. Dimitri, do you see it now? Great. No problem. How about you, Sue? Did you understand it now?
Definitely. Yeah. Thank you.
Great. Thank you guys for asking all these questions. It makes me happy. Okay, so we're done with discrete random variable. Now we are going to binomial random variable. So from its name, we can already guess binomial. It means you are working with something related to 2. Bi means 2. So binomial random variable, it's working with something that has only 2 outcomes. For example, when you flip a coin, we have either head or tail. So it's binomial. Or when you answer some true-false questions, there are only 2 possible choices, true or false. So it's a binomial. So anytime you're working with something that has only 2 possible outcomes, we use binomial distribution there. And to use binomial distribution, we use Bernoulli trials and we use Bernoulli's theorem. So Bernoulli trials means your experiment has only 2 outcomes. Bernoulli's theorems means we put together an equation that helps us to find the probability for each outcome. So it says if P is the probability of success and Q is the probability of failure, where Q is 1 minus P, then if you do an experiment exactly R times, so if you do an experiment N times, but you want to get R success, the probability, the way you can find the probability is NCR times the probability of success to the power R times the probability of failure to the power N minus R. So this is the formula, a very useful formula that helps us to figure out all the probabilities. You may wonder, why do you care about the probabilities? Well, if you observe the discrete, all those probabilities are given to us. But for binomial, they will not be given to us. We need to find the probabilities. How are you going to find it? Well, using this formula. Now, binomial distribution is used when there are exactly 2 mutually exclusive outcomes. For example, when you have true, it definitely cannot be false. When you have false, it definitely cannot be true. So they're mutually exclusive. They have nothing in common. Or similarly, if you're looking for head, you're not looking for tails. And when you're looking for tail, you're not looking for head. So they're completely disjoint events. So when we have 2 disjoint outcomes from a trial, one, whatever we are looking for, if you get that, we call them success. And if you don't get that, we call them failure. So binomial distribution is a graphical representation of the results of the Bernoulli's trial. So boundary trial says do the experiment as many times as you want, and distribution means whatever results you get, put them together. So when you put them together, the result, whatever you get, that's the binomial distribution. Now, when do you use it? For example, if you have 20% of the customers in your grocery stores use express checkout, consider 5 randomly selected customers. So by observing the population, we figured out that 20% of the people who comes to shop, they use express checkout. Now we are observing randomly 5 customers. What is the probability that at most one from those 5 use the express checkout? Well, this scenario falls under binomial because either you used the express checkout or you did not use it. So you have only 2 outcomes. And let's just do one of them here. The rest we are going to do in our next class. The probability of at most one used in the express checkout, at most one. What does at most one means? Maximum one, right? So either nobody used the express checkout or only one person used the express checkout. This is what at most one means. That means we need to see what is the probability of 0 and what's the probability of 1. Well, they did not give us the probability, so we have to find it. The only thing we know that 20% people use the express checkout. That means our success rate is 0.20. And we have 5 people. Now here we have 5 people, 0 people use express checkout with the probability 0.2. So whatever we have here, that goes on the power of the success. So if P is 0.2, that means our failure rate is 1 minus P, which is 0.8. So the failure to the power 5 minus 0. So this thing, probability of nobody used express checkout is this whole thing. That's the probability. And now we need to find out what's the probability that 1 people used express checkout. So here we do the same thing. We observe 5 people, 1 of them used express checkout. Now 0.2, the success rate to the power 1 and the failure rate to the power 5 minus 1. Now choose, we have a formula, n factorial over r factorial, n minus r factorial thingy. So if you don't use if you don't use calculator, it's 5 factorial over 0 factorial, and then 5 minus 0 factorial. And then anything to the power 0 is 1, so you get 1, and then times 0.8 to the power 5. For the next one, we have 5 factorial over 1 factorial, 5 minus 1, which is 4 factorial. And then 0.2, you multiply with 0.8 to the 4. Whatever that is, that's the answer. Okay. So we don't know our probabilities. So we need the help of the Bernoulli's formula to get the probability. And then we are going to do rest of the questions in our next class. If you want, you can try them in home. So when you do it together in our next class, you can simply give me the answers. Any question, guys? Sure, I'll start with the same question again in our next class. But remember, binomial means means 2. We have only 2 choices in our outcomes. Okay, you can start doing the homework. They have many examples on discrete and also binomial. you can start them, and we'll start with this example in our next class. I did not take the online attendance because most of you actually responds. So I was like, okay, no problem. I'm not going to take the attendance. No problem. So have a very good weekend, everyone. Be safe. Study smart. Thank you. Thank you, everyone. Thank you,
Professor?
Tal. Hi,
Professor?
Daphne. Huh?
Hi, I was wondering if we can, is it possible to open the homework? Because I wasn't able to do one of the homeworks because first my computer, like my laptop wasn't working, and then I got a little sick and I wasn't able to attend
Which
the
homework
lecture
you're talking
either.
about?
The homework, on
Chapter
the
1, 2, 3,
website.
4, those?
Yes, yeah.
Okay, no problem.
Thank you so much.
Uh-huh.
Bye.
Bye. Thank you, everyone, for your participation.